Okay, we're going to move on to section 1.2, and this is where we get to start talking about different ways of displaying quantitative data using graphs instead of, previously we talked about how to display categorical data using graphs, okay? One of the simplest graphs that you can construct in statistics is a dot plot, and it's actually used a lot. I think one, because it is so easy to construct, but it also tells you a lot about the distribution of data that you've collected. Okay, so when you make a dot plot, essentially you are going to take each data value and you're going to place it as a dot above a number line. And this box here explains how to make a dot plot, but I'm just going to show you and kind of talk through this down here because it's pretty simple. You have basically a number line that you scale and count by like whatever equal amounts here. We're counting by twos. This is talking about the number of goals scored per game by the 2012 U.S. women's soccer team. So you'll see this is a graph. A dot plot is a graph. So you should always label your axes with context. So I'm identifying that these numbers along here are representing the number of goals scored. And then we have all this data. I'm not sure how many pieces of data there are here, but each piece of data simply is placed right above as a dot whatever the number of goals scored is. And so you can see that there are 5 dots above a 2. That's because in this set of data there would have been 5 different times that this particular U.S. women's soccer team in 5 different games scored 2 goals. Okay, and you see these extra dots over here, so you know that indicates you learn a lot when you look at a dot plot. And so we're going to talk in this section about a very, very important aspect of studying distributions here. And the whole purpose of a graph, whether it's a dot plot or even a bar graph, is to try to understand the data. So after you've made a graph, you always want to ask yourself, what do I see? Okay, what do I see? And there are certain things that you should look for, okay? And there are a lot of acronyms in AP statistics, and so I'm gonna give you one of those here today, but we'll start here with, in any graph, you wanna look for an overall pattern, okay? An overall pattern, and for any striking departures from that pattern. Okay, that's what we would refer to as maybe being an outlier or some type of unusual value. And we can see that, wow, there were a couple games where they scored 13 goals and 14 goals here. Okay, those are striking departures away from the overall pattern where most of the goals were between 0 and 5. Okay. The other thing is you want to describe the overall pattern by using these 3 things. Okay. We want to always describe by the shape, by the center, and by the spread. Okay. And we're going to break these down here. And then at the bottom here, you want to note any individual values that appear like they're falling outside of that overall pattern. And these departures are often referred to as outliers, okay? So here's going to be our acronym that's going to help us anytime you are asked to describe a distribution. There are 4 components that you need to make sure that you are using. Okay, and we're going to use CUS as our acronym. Okay, the C stands for center. So you want to describe, here's the centermost value. This would be maybe, whatever that center dot is, we would call that the median. Okay, the U is for unusual values. Okay, we would call those outliers. Okay, unusual values. And then the first S is shape, which we'll discuss here in a moment. And the last S is spread. How spread out is the data? What is it spanning? Looks like this goes from 0 to 5 with then 2 outliers here. Okay. CUS. This is the acronym that we want to remember. And I always like to add BS at the end of it. And what the BS stands for is be specific, because when you are describing a distribution, you need to use context, okay? And I'll show you what I mean by that when we look at an example here, okay? So let's first talk about shape, okay? When you are describing the shape of a distribution, you want to look for symmetry, okay? Is it symmetrical or is there some skewness, okay? Look for symmetry or look for skewness, okay? Here's what I mean by that. A distribution, and it's almost never going to be perfectly symmetrical, so you're going to use either the word roughly symmetrical, or you could exchange the word roughly for approximately symmetrical. It is good to put that in front of the word symmetrical there, but a distribution is considered symmetrical if obviously the right and left sides are about mirror images of each other, okay? It is considered skewed to the right, okay, or you could call that right skewed. Sometimes it's called positively skewed if it's skewed to the right. Okay, if the right side of the graph is much longer than the left side of the graph, okay, here's what I like to do. You can see these 3 dot plots at the bottom, okay? We have 3 different dot plots. It is helpful if you just kind of run your pencil over top of those dot plots, and then you get a better sense of the shape, okay? So if you don't actually do this on your paper, it's good to at least visually do this kind of like mentally in your head. Picture drawing a curve over top, okay? So of these 3 graphs, the one that appears to be skewed to the right is, we're looking for, where is there a much longer left side, okay? Much longer, this looks... I'm sorry, I said that wrong. I feel like maybe I just highlighted this part a little bit incorrectly here. Okay, the right side of the graph, well, I guess that's okay. The right side of the graph has to be much longer than the left side, okay? So I like to think of it as it has a long right tail, okay? So when you look at the curve, you can see here, this one here, because I had to scoop this all the way around to include these dots over here, this has a long right tail. I'm going to call this one skewed right. Okay, skewed right. Okay, and then obviously it's considered skewed to the left if the left side is much longer than the right side. And so you can see in our dot plots here below, it might not be quite as prominent, but there definitely is this more elongated tail over here. A lot of times we use words like, oh, it's slightly skewed left. Maybe I'll just throw that in here, slightly skewed left. Certainly felt like this one over here was more skewed than this one. Okay, but there is a skewness visible there. And then in the first one here, I'm going to call this approximately symmetrical. Okay, sure, it's not exactly symmetrical, but this is more symmetrical than it is skewed. Okay, so those are the shapes. Okay, now we're going to look at this example, which is going to discuss kind of comparing 2 distributions. Okay, we want to compare 2 distributions. I see this a lot on AP tests. Okay, some of the most interesting stats questions involve you comparing 2 groups, and when you're doing this, these are the 4 components. This is what we mean when we talk about CUS, okay? And it can be in any order, but your outliers are your unusual values. We've got the spread, we've got the center, we got the shape, okay? Now, here's the trick. You have to be specific. So you have to use context, and when it asks you to compare, you need to use what we call comparative language, okay? Words like greater than, more, less, Okay, so when you're talking about the spread of this, or the center of this one is more than the center of this one. Okay? So here's what we're looking at in this example. It says here that this is the distribution of household size for two countries. So here we're talking about South Africa, the number of people living in a house, versus the UK, number of people living in a house. Okay, I'm just going to go ahead and draw a curve over top of this, and there's this point way out there, okay, and then I'm going to draw a curve over top of this, okay. So we want to hit all aspects of CUS. The order you do this does not matter. I'm going to go ahead and just start with shape, okay. Now, when you do this, you should not list the shape of each one individually, but you want to try to tie these together so that you're using comparative language, okay? So, and notice that I'm going to be specific and I'm going to use context. I'm just not going to say South Africa's skewed right, UK approximately symmetrical, okay? I didn't even say what the data was referring to when I say that. So I want to say something like the distribution of household size. That's what we mean by saying be specific and include context. So the distribution of household size for South Africa is skewed right. And then I'm just going to say whereas the UK is roughly, could say approximately, that'd be fine, symmetric, okay? They're tied together in one sentence, okay? I'm comparing the two, okay? Let's go ahead and shift over here to center, okay? Now, we want to find, first of all, what is the center of each of these? Now, I don't know if it exactly tells us how many dots there are here. I'm going to start on the left. Let's see, 1, 2, 3, 4. Okay, there were 50. Okay, there were 50 at least in South Africa. So if I want to find the center, I'm going to start at the left. I'm going to work my way from left to right until I hit where the 25th dot is. Okay, so the 25th dot. Okay, 25th dot is landing right here, which is probably at 6 people in the house. Okay. If I were to do that same thing with this distribution down here, we're looking at the middle dot in this distribution falling right there around 4, okay? So I know that, I'm thinking using my comparative language, that the number of people living in a house in South Africa, that's going to be greater, the center, it's greater than the center for the UK. So I'm going to say SA for South Africa. The South Africa distribution is centered at, I'm going to put the word about here, at about 6, and then here's me being specific and using context, at about 6 people per house, which is higher. Ooh, I'm going to highlight that. They will look for that when they grade your AP test, that you used this comparative language. It's higher than the center of the UK distribution, and then I'm going to say what that is. 4, I'll say approximately, I'll put those wavy lines, 4 people per house, okay? So if I'm doing this CUS acronym, I've done the center, I've done the shape, okay? Now I'm going to shift down here. I'll go ahead and do the U in CUS is unusual values, which is also where we would say these are outliers, okay? Now, as I look at this, it doesn't really feel like the UK has any unusual values, but it certainly feels like maybe 26 here is an unusual, like a large number of people to have in a house, even in South Africa. So I'm just going to say the UK doesn't appear to have any outliers. However, see, I'm just kind of tying this all together. South Africa looks to have one possible outlier at, and if I just say 26, I haven't really addressed the context. I want to say at 26 people per house. Okay, so now I've done the U in CUS, the unusual value. So there's another S, and that S has to do with the spread. So I want to compare the spread of these. Okay, now spread is talking about the span. Okay, how much is the data spread out? Well, clearly South Africa has a much larger spread than the spread of the UK. Okay, so again, you want to use these comparative words and maybe say something like the South Africa distribution is, I'm going to choose the word more variable, or you could say more spread than the UK distribution. Okay, and then I'm going to cite some evidence. Like that's what they're looking for. See, the evidence that we used for the center is us giving those numbers. Here's evidence for our unusual value. And now I'm going to cite some evidence for the spread. Okay, so I'm going to say that since I listed this in order, I talked about South Africa first. I'm going to say that's between 3 and 26 people per house. Versus the UK looks like maybe it's 2 to 6. That's the spread, or what it spans, people per house. That's my evidence, okay? This is what you do when you're asked to compare two distributions, okay? All right, so let's go ahead, and I think that brings this video actually to a close, and we'll pick up on the notes with the next video.